practice what we just looked at, and then go back to marginals. If you have the book brought up, or if you have it handy, you can choose. If not, I will. I'm on page 267. Okay. Let's start, let's say, with problem 30. 267, a practice for what we just looked at. We're given a function which is f of x, x minus x squared. We're given x, which is 3. And we are given delta x, which equals dx, of course, equals 0.2. As you see, dx is a minor error or minor change in x, 0.02. They're asking us to find delta y and also find dy. These are the questions. Good. The answer has to be, the two answers have to be very close to each other. Why? Because we know that delta y is approximately dy, especially because in this case it's going to be quite close because dx is 0.02. Of course, this part is going to be more difficult to calculate, slightly more difficult than this one. I'm going to start with dy. dy equals f prime of x dx. F prime of x will be 1 minus 2x times dx. And I just have to plug in the numbers. 1 minus 2 multiplied by 3. That's what I have. Multiplied by 0.02. So 1 minus 6 is negative 5. And negative 5 times 0.02 is negative 0.1. Please check my numbers. Sometimes I think of the next step and I mess up the numbers. And I shouldn't. Okay, so this part is calculated already. Now let's calculate this side, the delta y. So the delta y is f of x plus delta x minus f of x. Okay, x plus delta x is 3 plus 0.02. So I have f of 3.02 and minus f of 3. So 3.02 minus 3.02 squared minus f of 3, which is 3, but plus 9, because I have to distribute a negative sign. See, this is more cumbersome. So 3.02 minus 3.02 squared, keep an eye on my numbers, and then plus 6. And I got negative, it has to be very close, 0.1004. So this is the delta y, and this is the dy. This is the approximate, this is the exact. Can you live with this error? Yes, I can. On the 4th decimal digit, yeah, I can live with this error. Okay, another application of what we just looked at will be something like let's look at the cube root of 1005. And this is problem 39 on 267. And you could say, what is this? Very simple. It's approximately f of x plus f prime of x dx. And you can say, what's this? Very simple to identify from here. I need to identify the function. I need to identify x. I need to identify dx. And after that, I need to find f prime. Can anyone give us any of these? Anyone? Is anyone paying attention? Anyone?
I am. I'm trying to find the derivative.
No, the function is the cube root of x. X is 1,000. dx is 5. So f prime will be, because this is x to 1 over 3, so it's 1 over 3, x to 1 over 3 minus 1, which is negative 2/3. So it's 1 over 3, the cube root of x squared. So this is using calculus. You can determine an approximation of anything that you would normally not do by hand. Now this equals. This is indeed equals. This is not. So f of x will be the cube root of 1,000 plus f prime of x is 1 over 3 times the cube root of 1,000 squared, and times dx, which is 5. You can say 5 is big, so I will get a big approximation. I would say that 5 is big, but when it comes to the cube root of 105, it may not be. So this is 10. This is 10, but it's squared. The cube root of 1,000, it's 10, but it's squared, so it's 5 divided by 300. And I will simplify, and I get 60. So 10 plus 1 over 60 will be 601 over 60. I would not believe if you would have told me that the cube root of 1,005 can be approximated by 601 over 60, that you knew that. I would not believe you. But yes, I'm checking my work. I always do. So 1,005 raised to power 1 divided by 3. And then I have 601 divided by 60. And the error is at the 4th decimal digit. So that's how powerful calculus is. Okay. Before we look at the marginals, just one last example. I think I'm on page 6. Yes, I am. For example, let's say 44 on 267. And we have y equals x cubed 2x plus 5 squared. And we're asked to find dy. I wanted to understand the difference between dy and y prime. They're not the same. dy will be f prime of x dx. In this case, dy will be the first function prime, 3x squared times 2x plus 5 squared plus x cubed times 2 times 2x plus 5 times the inner function prime. And yes, I will factor out 2x plus 5. And then I have 3x squared times 2x is 6x cubed. 3x squared times 5 is 15x squared. This is out, so 4x cubed. Times dx, of course. Good, so 2x plus 5. Oops, I wrote x twice. There was no need to write x twice. So 2x plus 5 in parentheses. And then this is 10x cubed. Yeah, I should have factored out an x squared as well. I just realized that. 10 plus 15x squared. And I will do it right here, right now. So x squared, even 5x squared, 2x plus 5. So x squared is out, so this is 2x plus 3 dx. What is y prime equal to? All this without the dx. 5x squared, 2x plus 5, 2x plus 3. This is a very big difference because you will see what happens in chapter 4. So dy is this, y prime is just that. Okay, and finally, we can look at marginals. So any questions, please? Anyone? Let me stop for a moment. Any questions?
last problem. How did you get x and dx?
Say that again, please. Always stop me if you have questions. Always. That's never an interruption. So I'm not sure I understand the question. Can you say it again?
For number 39, it said, how did you
Oh,
get x?
39, the
Yeah.
previous problem. Sorry. What did I do?
How did you get x and dx?
Oh, by inspection. So obviously it's the cube root. So the closest to the cube root that I can apply to this number is 1,000. So obviously the error from 1,000 is 5. Because I can take the cube root from 1,000.
Okay.
But the cube root, it's a very good question, actually. Thank you for asking that. Don't let me move on if you have questions, please. I love the interaction, and I know that at least somebody is paying attention. So, because I see many people I cannot even see. So thank you for asking. So by inspection, basically. So I look at the cube root. Obviously, the cube root is the function in the problem. And the 1,005, it tells me that the x is basically 1,000. And the minor error deviation from the cube root of 1,000, which will be 10, is 5. And then once I have the function, I find the derivative, and all I have to remember is this. And I don't have to remember it. I just have to know what they mean. Delta y is approximately f prime of x, dx, or dy. I just need to have this in the back of my mind, and then the rest flows. Is that better?
So if it were a similar problem, you just have to see the margin of error. So if it was like 2005, it would still be the same process, the same number.
Well, it depends. It's a very good question. If you look at, we can look at other problems. For example, what do you think? Good question. So there are other problems on page 267 at the bottom. So for example, in problem, in the square root of 8, what do you think x, that's problem 36. What do you think x and dx will be? In the square root of 103, in the cube root of 28. I'm copying all of them now. In the square root of 102, in the square root of 26. What do you think x is here?
It's 2.
We are talking about as close as possible, so x equals 9. If you go from 2 to 8, that's a huge error. And you cannot take the square root from 2. Right? So in this particular case, it's basically 9 minus 1. So your x is 9 and your dx is -1. What about 26? What will x be and what will be dx? Remember, dx cannot be bigger than x. So if I consider x to be 2, then the error is 6. That's not possible.
X will be 25.
Right. So here x is 25 and dx is 1. What about this one?
Would it be 27?
Very good. Awesome. And 1. What about here?
It'd be 100.
Exactly. And of course here the same thing. X is 100 and dx equals 3. Dx has to be a tiny error. As tiny as possible. Right? Dx is tiny. It cannot be more than
That makes sense.
it can. Very good. Thank you. The questions are so important to me because they make me a better professor in the sense that, oops, I didn't say that. It wasn't clear what I said. So yes, I it appeared to me that it was clear, but I should have said it. Of course, dx has to be tiny. It can never be more than x, of course. It has to be 1, 2, 5, but definitely not more than x. Very good. Thank you for the question. Thank you. Okay, so finally, based on this, we are going to look at what is called marginals. Other questions for me? Marginals. Okay, so you are familiar. We've looked at the cost function, the revenue function, and the profit function several times in different problems. So what is the so-called marginal cost? Is c prime of x, and it's the approximate cost of the x plus first term. So in other words, when we write c prime of x, this is basically approximately c of x plus first minus c of x. Where does this come from? Three pages ago, I thought it was 2, but it's 3. It comes from here, where f prime of x, dx is 1, and this is c of x plus 1, and this is c of x. So it's the same with saying delta c is approximately dc, where delta c, where dx is 1 as a specific case for the marginal, and then we have the c of x plus 1 minus c of x equals c prime, approximately c prime of x dx, but this is 1. Why we write it vice versa, it doesn't matter really. Your book writes it as s prime of x equals this, but it's the same thing. The same, everything the same for the revenue, for the marginal revenue. It's r of x plus 1 minus r of x. Of course, for marginal profit, the same thing. The profit of x plus first minus the profit of x.